Day 42, honors energy, problem 29. Like a lot of problems, this will have a couple different ways that you can solve. But here's my basic diagram. The block is 8 meters high on a ramp. It's also moving with a speed of 5 meters per second. It's going to go from point A to point B along this ramp. The beauty of doing this with conservation of energy, we don't need to worry about the angle of the ramp or how it's curved. These are scalar quantities, so all we do is look at the energy at point A, which is a combination of kinetic energy and GPE. So bottom left here, I've calculated the total mechanical energy to be 278 joules. There. So when you get to point B, it has that same amount of energy, but it's all kinetic. So you could figure out the energy at point B, or the velocity at point B. We know the energy is 278 joules. It did say that it was a frictionless ramp on the way down, so we didn't lose any mechanical energy. Now once you get to point B, there's a rough surface, which I've indicated with a blue squiggle. From points B to C now, you're going to lose all your kinetic energy. You're turning that kinetic energy into heat energy. So I'm looking at the process from point B to C. The work done by friction, or the work done by any force, is F times D. So on the far left over here, I have that. The force that's being applied up here and out the top is the frictional force. So I've drawn the free body diagram, and I've calculated the force of friction using the equation from last unit. You take the coefficient of friction times the normal force on a flat surface. We're talking about from B to C now. We're not on the ramp anymore. So the frictional force is 9.6 newtons. What you will need to do is you'll need to take this total mechanical energy here, this 278. That'll be the work that friction needs to do. In other words, to rob that energy, that mechanical energy, and turn it to heat. So plug the 278 in for W, and then solve for D. And just to repeat then, the friction is going to do work to take away the mechanical energy and transfer it to heat. The block will come to rest with no more mechanical energy, but there will be heat energy in the surface and in the block.